So now that we understand the concepts of high availability and disaster recovery, let's see how these are ingrained within our global infrastructure. So what are the objectives of this session? So we'll understand what comprises of a global infrastructure. So how do we divide the infrastructure into regions, zones, and edge locations? We will see, how the resiliency and the fault tolerance is built inside the global infrastructure. So let's take a step back and try to see how the cloud infrastructure looks like from a helicopter view. We will start from the ground level and then we will move our helicopter up in the air and let's see how the cloud looks like. So at the basic level, we have got a server. So this is the very core of any cloud system or infrastructure. Then we have a bunch of servers. We start laying down a bunch of servers, more servers together, stacked together. So all these servers or the farmer servers, they sit inside one location, which we call a data center. So the definition of data center is imagine a data center as a building where we have a farm of servers sitting together and working for us. And then if we move up from a helicopter view, so we see data center as a single building, and there may be some other data center which are co-located, located within a few miles or kilometers from each other. And if we club all these data centers together, it forms a single zone. So the set of servers reside, or the farm of servers reside inside a data center. The bunch of servers, we call it a zone. And similarly, there can be different zones which are geographically separate. Data centers are located a few kilometers or miles away. A zone can be, let's say, hundreds of kilometers or miles away from each other. And if we club together all the zones, we get a region. And similarly, if we combine multiple regions, what we get is we get the entire ecosystem, the cloud infrastructure. We call it global just because our infrastructure is available in different regions. So this can be in North America, South America, Europe, Asia. So it can be available anywhere. That's why we call it a global infrastructure. Let's see a definition of all these one by one. So let's start with the region. So what is a region? A region is defined as a geographical area. So usually on a map, so we pick up a geographical area, which we say it's a region. So the communication between a region uses backbone network infrastructure. This is a very important point to understand. Like most cloud providers, let's say Google or Microsoft, what they have done? They have their own fiber optic cables, which they have actually connected their regions together. So all their communication or the network traffic is actually carried out by their own network infrastructure. So that becomes the backbone of network, and that carries or communicates between the regions. That is how you have a very low latency. Next important thing to understand is each region provides full redundancy and connectivity to the network. The important point again, full redundancy. We talked about high availability. High availability means we have to have a system which is redundant. And here we are talking about a region. A region is fully redundant. That simply means the region is highly available. How? A region consists of two or more availability zones. We saw that bunch of zones creates a region. Now I've used a word called availability. Just to achieve high availability, we have different zones. If one zone goes down, we have another zone which takes up. And even within these zones, we can have further partitions. Let's go next. So how do we select a region? It's again important. From the architecture standpoint, it's important, how do you decide which region you're going to provision your application? We are talking about a cloud which is spanning across the globe. So how do you choose? Let's say, how do I choose if I have to deploy my application in a particular region? The very first thing is the data governance and legal requirements. So we all know about the GDPR requirements in Europe. They clearly say that any customer data which you have can only be stored within the European boundary. They cannot go outside. That becomes your primary choice for the region. If your application have the personal data from a customer which is in the Europe, so it has to reside in a European region. That's how you choose the region. Second thing is proximity to the customer. If a region is close to the customer, definitely you will see low latency. Low latency in accessing your system. Within a fraction of a second, the data will be available to you. Third thing is the services available within a region. So this is also important. So the cloud providers, they are introducing new services day by day, but those services are not available across the entire infrastructure in one go. So usually I've seen like most of the services, they start coming up from America, the North America region. They go to Europe, then Asia, right? That's how they expand their services. So what services available within a region, that also becomes your primary choice. Which region are you going to choose? And then it's a cost. So to deploy an application, let's say in European region versus deploying an application in America. So they're two different things. The cost comes into picture. The cost may vary. Okay, if you remember carefully in one of our lecture where we're talking about cost and pricing and all, so we were using calculator. We found that using a calculator that the cost varied when we moved away from the European region. Even within a European region, I really remember we saw how moving away from Ireland to London, if we use that, so there was a difference in cost. Okay, so this is also important when you select a region, you know how much the cost will be. Next thing is zone. As I said, the zone, each region has multiple availability zones. Now each zone is fully isolated partition. So that means when we talk about region, which is separated into zones, so each zone is an isolated partition. They operate in isolation. Imagine having a different system which operates in isolation. A zone consists of discrete data center. We know that a zone consists of data centers. They are divided into data centers just because of our fault isolation. Let's say there is a fault in one of the data center. Okay, within a zone, still your zone will be highly available because you can rely on other data centers which is within that zone. So this is how it looks like. This is an example of the AWS cloud. In the AWS cloud, let's say we pick up a Europe West 1 region. So EU means Europe, the West region we are talking about, Europe West 1. In Europe West 1, we have got a bunch of zones. So one of the availability zone is Europe West 1A. So this is just a nomenclature. So within this availability zone, you will have different data centers. You see these 3 data centers here. Similarly, there will be another availability zone, Europe West 1B. There will be multiple data centers within this availability zone. And then there will be another availability zone, Europe West 1C. And in this Europe West 1C region, you will have multiple data centers. This is how it is done. If you see, you will have at least 2 or more than 2 data centers. You will have at least 2 or more than 2 zones. Why? You saw so when we talked about high availability, we saw that we should have at least 2 systems for this to become highly available. That is the reason you have at least 2, but usually I've seen at least 3 or 4 regions or data centers which are available, just so that you have enough redundancy, enough of your fault tolerance available so that you can be highly available. Next thing is edge location. This is a very important thing from perspective of the content delivery. So they are called a point of presence. So this brings the cloud traffic closer to the peers, thereby reducing cost, latency, and providing end user with a better experience. I'll give you an example. So this, I was talking about the content delivery network, which uses edge location to deliver the content to end user with low latency. You talk about Facebook, right? The Facebook, if you see, if somebody uploads a photo, let's say in Asia region, so it gets replicated to the America or the European region, and the person who is accessing the same picture from Europe will get that picture image pretty fast. How? Because of the content delivery network. So the edge locations have cache. So they cache the data, and as soon as a user goes and try to cache the data, they will not have to go and look for the image which was there in the Asian region. They will see where it is near the vicinity, and then they will access it. So that's how the regional edge caches are used for the content which is accessed frequently or infrequently. I'm just showing you how there are different regions and then there are different edge locations on within a region. So now what are the features of the global infrastructure? It is elastic and scalable. Elastic in the sense means you can adapt to the capacity. You can move up and down the capacity what you want. You can similarly scale the infrastructure. And if you're growing, you can add more servers to the infrastructure. You can add servers within a region. You can add servers outside of the region. Next thing is fault tolerance. Just because there is a failure within one data center, you can always fall back within the second data center. So there's a fault tolerance which is available. Just because of this fault tolerance, we are building redundancy. So because redundancy is a characteristic which defines how your application will be available. So we have got a built-in redundancy. We don't have to worry about building high availability or we don't have to take care about a disaster recovery. Everything which we get is inbuilt. Just because we have redundancy and fault tolerance, we can say our systems are highly available. High level of operation performance is what we get, and we get a very minimum downtime. Very, very, very minimum downtime. So what we have learned so far, we understood what comprises of a global infrastructure. We saw how the infrastructure is divided into regions, zones, and edge locations. And then we saw the features of infrastructure, that is elasticity, scalability, fault tolerance, and availability. So that's it for today's session. See you in the next one. Thank you.